All right, here we are. We're going to look at 4 different functions: polynomial, rational, exponential, and logarithmic. Now you might be saying, hey, Prof. Resi, we only talked about exponential. What happened to the linear and the quadratic? Well, they're going to get wrapped up into polynomial functions. Now, at first, this equation looks kind of scary. So let's just skip the equation for now and we'll talk about the graphs. The graphs of a polynomial functions could be linear, they could be parabolas or quadratics, they could be cubics. Here's the key: they're a smooth curve without any breaks. And so I've got some examples here. You can see linear, parabola, upside down parabola. This is probably a cubic. This is a polynomial as well. So anything that's a smooth curve without any breaks in it is polynomial. Let's go back and look at the equations. So if I looked at a linear, it would look something like y equals mx plus b. Okay, so maybe y equals 1/2 x plus 5. And exponential, y equals ax squared plus bx plus c. And you don't have to memorize these or anything. These are just the standard forms that you might have seen before. I don't know what this equation is, so I'm just completely making this up. But if I did y equals x squared plus 3x plus 5, that might be an example there. If I get into a cubic, that might be something, again, I'm sure it doesn't match, but x squared plus 2x minus 2x squared minus 6x plus 4. Okay, or y equals x to the 4th plus 5x minus, or cubed, minus 6x squared plus 2x plus 8. Okay, now, these are not correct equations for these graphs. They are just equations, and they're just sample equations. And what I'm trying to show you here is, you see how this x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, that's what this is saying. X to the n minus 1, so on, down to x squared, x. And then a0 is a constant. These a terms are just numbers. And so if you see an equation that looks like this, you know it's a polynomial function. If you see any graphs that look like this, you know it's a polynomial function. And really what I want you to be able to do for this section is I want you to be able to look at a graph and say, hey, I think that's polynomial. Or I want you to look at an equation and say, hey, I think that equation is polynomial. Okay? So let's move on to rational functions. Okay? So again, the goal here, remember, is just to be able to look at an equation and say, hey, that equation is a rational function, or exponential, or logarithmic. So the key here with rational function, it's a quotient of 2 polynomial functions. You'll probably think of these as fractions. So if you see something like y equals even 1 over x minus 1, okay, that would be a rational function. Or y equals x over x squared minus 3x. That would be a rational function. You see, it's a polynomial function divided by a polynomial function. Okay, the graphs, the giveaway on the graphs is that there's either holes or vertical asymptotes. You might think of them as breaks in the graph. So here's an equation. This one is probably going to be similar to y equals 1 over x. Okay, so that would be one example. Here's another vertical asymptote. They might have multiple parts or pieces to it, and you can see the vertical asymptotes here. And here's another example. And so those are rational functions. This one is exponential functions. These you're probably a little more familiar with. These equations have x in the exponent. That's the key. So you might have like y equals 2 times 3 to the x. Or the one I had earlier is y equals 6 to the x. Or you can even have fractions with them, like this. I think there was one on the homework a few weeks back. 2/5 times, I think it was 5 to the x, something like that. Anyway, exponential functions start off with a horizontal asymptote. Those are here in both cases. And they start off slow and then they explode with growth, like the strawberries. Or else they decay quickly and then taper off in like a half-life. So that is exponential functions. Logarithmic functions are another function I want you to be able to recognize from the equation. These are fairly easy from the equation because they have typically the word log in them. So you might have like y equals log base 3 of x, or there might be a natural log of x. This is a logarithm as well. Okay, so any equation that has a log in it is a logarithmic equation. These functions have a vertical asymptote, and then they level off. So they might almost look like they just end, kind of funny. They might not have an arrow on the end, but both of these would be examples of logarithmic functions. So just a quick review. The goal here is that you would be able to recognize these four functions from their graphs and from their equations. So you've got polynomial functions, which are linear, quadratic, cubic, quartic. Okay, they're in this format. Okay, they're equations. Smooth without any breaks. That's the key there. Rational functions are a polynomial function divided by a polynomial function, and these typically have breaks in them. Okay, and so you can see these here, and their equations have a fraction. I skipped one. Exponential here, the equation will have an x in the exponent, so it'll look like some of these, and it'll have exponential growth or exponential decay. The last one then is logarithmic functions. They'll have the word log or natural log in the equation, and those equations will look something like this. And so that is the kind of lecture for this section. So let me know if you have questions. Thanks, guys.